Professor Noi currently teaches 2 courses on economics of disasters, disasters and economics policy, and the economics of natural disasters and climate change. He's already published dozens of papers on climate change impacts and attributions and adaptation. And in 2017, Ilan and Professor Shunsuke, and I'm not sure whether it's Manaji of Japan, founded the Journal of Economics of Disasters and Climate Change. So now, without further delay, let's hear what Ilan has to tell us.
Hello, everyone. Thank you, Jeff, for suggesting and inviting me, and thank you, everyone, for attending. My intention is to try to talk a little bit about climate change, but I'm also very happy to pursue more of a conversation rather than a lecture. So if there are any questions or any issues that you want to raise while I'm, talking, then by all means, please, I don't know, raise your hand or just unmute yourself and let us know you have a question. I would much rather have that than wait for the whole lecture to go through and then ask questions. If anyone has any questions while I'm going, then by all means, please intervene. What I will do is first share my screen. So what Jeff asked me to talk about a little bit is climate change. I should note that my interest in climate change came about sort of not directly, because I'm not a climate scientist. I started, as Jeff mentioned, I started as an economist working on financial crises. And somewhat early in my career as an academic, I realized that natural events like earthquakes or big hurricanes and things like that have a very big impact on the economy that is not dissimilar to what financial crises do. So I changed my focus to look at these disasters. Initially, that started after the tsunami, the Southeast Asian tsunami in 2004, so almost 20 years ago. And sort of while I was doing that, I realized that actually the climate change problem is related, and I also started working on various climate change issues. Some of them related to natural disasters, and some of them not. Okay, I want to start actually by just showing you these figures from a couple of weeks ago from The Economist magazine. Before I do that, I don't know why this skipped. Yeah. First, I want to note that when we talk about climate change, we typically tend to talk about 2 things, and that is the increase in the average temperature. And I think you all know that there's been a lot of sort of debate and negotiations and discussion about whether the world is looking into our goal is a 1.5 degrees increase in average global temperature, maybe a more realistic goal, but still a goal that was stated in the IPCC and by the UNFCCC, by the United Nations process for negotiations, is a 2-degree world. While a lot of people think that we are actually on a trajectory to a 3 or 4 or 5 degrees world. So there's been a lot of discussions about the change in the average temperature. There's also been a lot of discussion about the increasing in the sea levels. Okay, and again, there are various projections about future sea level rise, and we also have some numbers about how much the seas have already risen in the past few decades, or essentially since the world started heating up as a result of the greenhouse gases that we've been emitting into the atmosphere in the past 100 and more years. But this is just a brief side note looking at those average temperatures. This looks both at sea surface temperature and global air temperature average. And what I want to call out, and maybe you are aware of it or not, is that this year is an incredibly unusual year. It is much, much warmer than we have experienced even in the recent past. And you can see that very clear from both these figures. These figures basically tell you what happened in the last 40 years in every year. So every year is traced there. On sea surface temperature on the right, you can see pretty much the whole year. In the global air temperature, you're seeing the northern hemisphere summer. But in both cases, we see a very, very unusual very unusually high temperatures this year. This is a combination of climate change, of course, and the fact that we are in an El Nino year. But something is clearly going on. This figure makes it very, very clear that the climate is changing. Now, my contention is, first of all, that while we are always focused on these average temperatures, this is not where the main cost of climate change is. The main cost of climate change is actually in the extreme events. So it's in the droughts, in the storms, in the heat waves, and in the floods, okay? It's not in the average global temperature. So when we are talking about 1.5 degrees or 2 degrees, or even 3 degrees, a lot of people think, if you live in Wellington like I do, you think, okay, 3 degrees, that's not really going. If every day of the year will be 3 degrees warmer in Wellington, my life will be a bit easier, not much worse. But actually, the point of a 3-degree world is not so much that every location every day will be 3 degrees warmer, but that we will have these extreme events, including very, very high temperatures, right? And only this year, again, this is an unusual year. There was the highest temperature ever measured in Europe, 48 degrees. Okay, 48 degrees is already, I think it was 48.2 actually. So 48.2 is clearly a temperature which is not actually for a long period of time, humans cannot survive that temperature. Okay. So my contention is, it is those extreme events that we need to worry about. So basically what climate change is doing, it is shifting the right tail of the distribution. And here we're just showing you the right tail of the distribution. And this is done for precipitation, but you equally can do it for temperature. And what climate change is doing, it is shifting that right tail of the distribution to the right. And then we can and then in this case, we can see that all these, the shaded area is basically the increase in precipitation that we observe, the increase in extreme precipitation that we observe as a result of climate change. Now, there are two ways to think about it. Either we can say that the precipitation events that involve high levels of precipitation are increasing in frequency, so they are becoming more likely, more often. That's basically the vertical shift in the curve. Or we can think about those events as becoming more intense. So those events of extreme precipitation are becoming more intense. That's basically the horizontal shift in the curve. So because the whole curve is shifting, it doesn't really make sense to talk about either a horizontal or a vertical. So it's basically we can see that frequency and intensity are basically two sides of the same phenomena. Okay, so if we think of an event like extratropical cyclone Gabrielle that hit Hawke's Bay and Tairafiti and other areas around the East Cape and so forth in February this year, if we think of it as, for example, at that point there, then we can either say that Gabrielle became more likely because of climate change, because without climate change, we would have been in a much lower probability. Gabrielle would have been a much lower probability event. That's the vertical shift in the curve. Or we can say that Gabrielle became much more intense because of climate change, and that is that horizontal shift in the curve. So both of these things are basically talking about the same phenomena, about that shift in the curve. And we know that for Gabrielle, indeed, in terms of precipitation, that precipitation did indeed become more likely because of climate change. Exactly the magnitude of increasing precipitation, so that the amount of horizontal shift that we observe because of climate change associated with an event like Tropical Cyclone Gabrielle, for the Gabrielle event, we have been unable to quantify that for various reasons having to do with the absence of enough observations and so forth. But we do know that horizontal shift has occurred. Okay, so what I want to do is briefly describe a few research projects that we have done using this idea of this shifting of the curve and what we call climate change attribution, which is looking at a specific extreme events that have already happened and identifying the climate change component. So either identifying the horizontal shift in the curve or the vertical shift in the curve, and then saying something about the economic impacts or the socioeconomic impacts. So in this case, this is a project that we started as a report for the Treasury back in 2018. The principal investigator on that was Dave Frame, who is a climate change, atmospheric physicist who now works at the University of Canterbury. And we looked at basically all the big flooding events of the decade before, well, when we started this in 2018. So all the decade between 2007 and 2017, you have here a list of all those events, all those flooding events, and the cost associated with them. This is the cost, the damages associated, the insured costs. So everything that was insured in those events by the private insurers. Why do I focus only on what was privately insured in those events? Not because I necessarily care about what was privately insured. Actually, I care more about what was not insured, because that has bigger implications for the economy. But I don't have numbers for that. I only have numbers for what was insured, because somewhat, I think, regrettably, the New Zealand government doesn't collect data on disaster losses. So we don't know how much losses we are experiencing because of disasters in New Zealand. The only entity that collects data is the Insurance Council, and they collect data from their members, which is the insurance companies, the private insurance companies. So that's the only data we have about the costs of extreme events in New Zealand. And I can later talk about why I think this is.
Ian?
Yes.
I just wonder if you can factor that, like from some experience, you can factor, you can have a ratio, you know, estimate a ratio, you know what I mean?
Yes. The problem is we don't have a single event for which we have data, comprehensive data. So it's hard to, I think the ratio would be quite different in different events. To give you an example, we had two very big events, and we'll get to them soon. We had two big events in Auckland, the Auckland anniversary floods in January, and then we had extratropical cyclone Gabrielle in February. If I had to guess, the ratio between them was very, very different, with a much bigger share for the private insured damages in the Auckland event and much smaller share of privately insured damages in the the Gabrielle event in February. Okay, for two reasons. Why? One is Auckland is much more heavily insured, so there would be a lot more assets that are private assets that were not insured in the second event. And second, infrastructure is a lot less public infrastructure, like roads and bridges and things like that, are not insured. So because a lot of the damages in the second event was infrastructure, especially transportation infrastructure, again, the ratio would be very, very different. But the ratio, I've seen estimates of between 4 and 10. So, overall damages are 4 times as much as the insured damages, or maybe 10 times as much. I think it's clearly somewhere between that. but exactly what it is, I'm not sure. And I think it would be very different for different events. Yeah. Okay, so we take these events, and then what we do is we estimate the fraction of that event that is associated with climate change. Okay, so how do you do that? Well, this is luckily for me, I'm not a climate scientist. I don't have to do that. The climate scientists in our team did that. Basically, you need to run a climate model of extreme events, and you run the climate model with the current climate, so with the amount of greenhouse gases that we currently have in the atmosphere, which is around, or at the time there was these events happened. So say today it's about 425, I think, parts per million of carbon dioxide in the atmosphere. And you also run the same model with the amount of carbon dioxide that we had in the atmosphere before we started adding to it, so around 280 parts per million. Okay, so you run the same model, and it's a small model that you run many times so that you can get at the extreme events. You run it many times with the 425 figure. You run it many times with the 280 figure, and then you can tease out what is that fraction of the risk that is attributable to climate change. So all we do in this report, or in later was an academic paper that we published, we then take the insured damages that the Insurance Council provides, and we multiply that by the share of the damage that is the share of the risk that is because of climate change, and then we can estimate what that event basically, the share of the damages from that event that is associated with climate change. Okay, and then we can sum it up, and we can say for this decade, it is a certain amount of damages. We do something also similar for droughts. Okay, so floods and droughts, and you can see that in the Treasury report that was eventually published, or in the academic paper that was published. By the way, all the papers that I'm talking about are available on my website. They're all freely available on my website. Most of them because I have copyright, some of them because I don't, even though I don't. But they're all publicly available if you want to consult any of this, if any of this work. So my private Google website has all of these papers. Now, if we look at this is the data, that is the data from the Insurance Council that I just mentioned. This now doesn't look at specific events. It looks at the overall insured events in the past 50-something years, 55 years in New Zealand. So again, it's only the insured losses, right? And then you can multiply that by whatever factor you think is the appropriate one to get at the overall damages from these events. But what we see, and this is sort of why I didn't really give you a total figure in the previous table, is that the decade that we focused on in that Treasury report was a decade that was much more benign than what happened after that. Okay, so after 2016, we see that events became much more costly. So the aggregate figures for every year since 2016 has been much higher than before. Okay, so in a sense, if I were to give you the actual figure for here, I would be vastly underestimating what is going on, because it's based on a decade that was now seems to be unusually benign. Okay, so I think
Ilan,
that figure underestimates the cost of climate change.
may I ask a question, please?
Please.
That's fascinating. There are a few other variables in there that I'd just be interested to know how they're factored in. For example, I presume it's corrected for inflation value, 0.1, and 0.2 is progressively as areas get built up, there is more stuff there to damage, and I'd be interested to know how the quantum of damageable stuff relates to those graphs as well, because it's not purely the intensity of the climate event, is it? It's what it's hitting as well that is factors those values, sets those values.
So first of all, inflation, yes, it's adjusted for inflation, so that's easy. But the answer about the exposure is a bit more complicated. Just let me go back here. So what I'm trying to do in this kind of exercise is estimate the cost of climate change, holding everything else constant. So whatever exposure there is, whatever the amount of assets there were, whatever the vulnerability of those assets was, we are holding all of that constant, and we are saying, let's imagine a world in which we had those assets, we had those people, we had, I don't know what the population of New Zealand was in, say, 2007, say it was 4 million, and now it's 5 million. So whatever the population and the assets and so on, let's assume that this is what was, and we're holding that constant. And then we're saying, if we look at the 2007, the second column there, the second row there, 2007, whatever there was caused damages of $72 million. 30% of that is because of climate change, so that means 21 million is because of climate change, whatever the other aspects. Now, generally, when we speak, so now to get to this figure, so in that sense, that calculation, it's irrelevant to talk about changing exposure and vulnerability, right? So typically when you think of any kind of disaster, a disaster is a function of the hazard itself. So it could be the extreme rainfall or the storm or the cyclone or whatever it is. And it's the hazard interacting with something that is exposed to it, so the assets that are exposed to it, and the vulnerability of those assets. And both exposure and vulnerability are changing over time, right? Exposure is in New Zealand, it's increasing, the population is increasing, the value of there are more assets, more population, and the value of the assets is increasing. On the other hand, vulnerability might be increasing, might be decreasing, depending on the circumstances. For example, for earthquakes, we are decreasing vulnerability because we are building better and better buildings, right? For flooding, I would say that we are not protecting ourselves much against flooding, so maybe vulnerability there is not changing, but exposure is increasing, okay? So I'm not going to conclude anything about climate change from this figure because I need to, as you suggest, I need to control for exposure and vulnerability, right? So what I said, sorry, just a minute. So I didn't turn my phone off.
Mm-hmm.
Sorry about that. So I was not saying that the last 5 years, this is only climate change. There's possibly other things happening there why it is increasing. Okay, and in order for me to say how much of that increase is because of climate change, I will need to have a model that also accounts for exposure and vulnerability, changing exposure and changing vulnerability. Now, if you look at this figure, so you see these past 5 years, this figures is actually taken from the Treasury report about the costs of climate change. This is a Treasury report that was completed earlier this year. Two observations there. The Treasury concluded that they have no other data, so they had to use only this data. They didn't have anything else. So that's why they're using this and not trying to be more comprehensive in their assessment. But for some reason, they issued the figure, the report was issued in 2023, but it only includes data up to 2021, so it doesn't include the 2022 data. I do want to note that 2022 was slightly higher than 2021, so it's just over 350 million in 2022. Now, 2023 is already about 9 times bigger than 2021 or 2022. Okay, so if you're looking at your screen, 2023 is already probably hitting the ceiling of the room you're sitting in, or something like that. So 2023 is a much worse year than we have ever experienced in Aotearoa in terms of privately insured damages. Now, in terms of everything else, we don't know because we don't have data on that. Okay, so when I'm saying that my assessment is based on this sort of decade that seems very benign, it also ignores the fact that the 2 years that you don't see in the figure, 2022 and 2023, are even much worse than previously, right? So even if only 10% of the damage in 2023 is because of climate change, and that seems to be the minimum. About 10% is probably an assessment of the sort of the lowest range of estimates. Then we're talking about 2023, which had a much bigger impact on climate change. The climate change impact of 2023 was much bigger than anything ever experienced before. Okay. So that's and I would actually love to do the same kind of analysis we did for 2007 to 2017 for these most recent years. At this point, we don't have the attribution assessments, the calculations that are required to do that. And whether we get funding to do that, I'm not sure. Another paper we have done with sort of a different group of people is a more, well, it is about the United States, so apologies for that. But it looks at a very specific, very big event. And because we have unique data there, we could do something that we haven't yet done here in Aotearoa, but we are hoping to do that as well here. And this looks at the impact of Hurricane Harvey. Hurricane Harvey was a hurricane that hit the city of Houston in 2017. As the president at the time, whose name I will not mention, he said that this was a very, very wet storm from the standpoint of water. What he meant by that, it's not entirely clear, but he was right. What was unique about this hurricane was not that it was very strong in terms of its wind speed. So it was only a Category 3 hurricane, but it dropped a lot of rain, and it dropped a lot of rain partly because of climate change, and that's why we focus on it. So for two reasons: one, the ocean was much warmer, so because of that, much more evaporation, much more energy in the storm, and therefore a lot more much more moisture in the storm, and therefore a lot more rain. And second, hurricanes travel more slowly when the air is warmer. And because it was traveling very, very slowly, actually got stuck over the city of Houston, it dropped a lot more rain on the city. So what we do in this research is we combine climate science, that attribution part that I already mentioned, with hydrological flood mapping of the city. So basically, we do flood mapping of the city with and without climate change. And then with some socioeconomic analysis, we try to say something more about the impact of climate change in this case. So just to give you an example of what we do, so the top figure is the way that the flood actually flooded the city. And then the climate scientists in this team calculate that probably around, the figure we use is 38% of the rain from that event was because of climate change. So Hurricane Harvey would still have happened even if there was no climate change, but it would have dropped 38% less rain. So we remove 38% of the amount of rain that actually fell on the city, and then we model the extent of flooding. Okay, and so basically try to conclude how the flood would have looked like without climate change. And not very surprisingly, there would have been less flooding if there was 38% less rain. But you can see that what we can do here from those maps is we can do a very detailed analysis, basically house by house in the city, and there are about 1.1 million houses in the city. House by house in the city, identify whether it was flooded, would it have been flooded without climate change, and by how much did it flood, and how much would it have flooded without climate change. So for example, you can imagine a house that was flooded with, say, 1 meter of water, and without climate change, it would have flooded by only 0.5 meter of water, or a house that was flooded by, I don't know, 35 centimeters of water, And without climate change, it would not have flooded at all. Okay, and we can identify that for every single 1.1 million houses in the city, out of which about 10% got flooded. So about 105,000 houses got flooded. And what do we conclude there then? And this is sort of the worrying aspect of this research, is that 38% of the rain was because of climate change. But out of the 106,000 houses that were flooded, 50% of them were flooded because of climate change. So if we remove 38% of the rain, we would have made 50% of the houses safe, so not damaged. Okay, and then when you look at the actual dollar value of the damages, it gets even higher, and it's 58% of the damages because of climate change. So if we remove 38% of the rain, 50% of the houses wouldn't flood, and 58% less damage than actually what was experienced during this event. This is only for the residential housing, right? We don't do any modeling for commercial or transportation networks and other issues. So here we focus on residential housing. Right. So you see this escalation in terms of the impacts of climate change from the climate phenomenon, the weather phenomenon, to the economic impact of that event. The other thing we can do is we can start to dice and divide the impact into different groups, different income levels, and so forth. And what we identify is somewhat surprisingly and somewhat worryingly, this is a figure of what happened to Hispanic-owned properties. Okay, so Hispanics are roughly 40% of the population in the city of Houston. And if you look at the houses that were insured or likely to be insured in that event, it's still about that 40% of them were in any of those A, B, C groups. So A is those houses that were not flooded at all. B is houses that were flooded, but wouldn't have flooded if there was no climate change. And C are houses that flooded and would have anyway got flooded, but they flooded more because of climate change. Okay. So for those houses that were insured, we don't see any sort of bias in terms of their ethnic ownership. But for those that are uninsured, we do see this bias, and there's a much higher share of Hispanic-owned properties for those uninsured properties that were flooded and were flooded because of climate change. Okay, so the storm, in a sense, had a bias. Now, of course, the storm itself had no bias, but whatever led to the spatial distribution of people in the city of Houston also caused that bias in terms of making Hispanics more exposed to this risk and be affected by the flooding, especially those that are uninsured. I don't have an analysis here, but it's also especially this is in the paper, especially low income. So the group that was hit the worst were Hispanics, low income, uninsured individuals or households. Okay, that's of course worrying because this is a very vulnerable population, right?
Ian.
Yes.
I guess what you're describing is the effects of inequality and how it sort of exponentially sort of activates itself with climate change. What I was going to throw a question at you just at this point was, what do you see how do you see the viability of insurance existing? Given the increase of everything and the component that isn't insured, how do you sort of visualize that going forward?
Yeah. Let me wait with that because I have a slide on that later on. Specifically in the context of New Zealand. I just want to note that just noting here what we talk about insured and uninsured. In the case of the United States, flood insurance is a public program, unlike New Zealand, where it's a private, you privately insure against flooding. In the US, going back to the 1960s, I believe, flood insurance is only provided by the federal government through what they call the National Flood Insurance Program. And the reason why people are insured and uninsured has to do with the conditionality on their mortgages. Generally speaking, a lot fewer people are insured for flooding. So only about 30% of the people in Houston that were flooded had flood insurance. So the majority of people that were flooded had no insurance at all. And that has to do with an insurance system that relies completely on a public program, a very inefficient public program, I would say. But the reason the public program exists is because the private insurance market is not willing to supply flood insurance in the case of the United States, and that already started in the 1960s. I will talk more soon about whether we should expect something similar to that in the New Zealand context in years to come.
I just have a question while we're on this subject. It seems to me that if you want people on board to change with climate change, then you'll inform them as to how directly impacted they'll be. This sort of research is very powerful for letting that happen. So governments that are in denial won't want this sort of research and won't support it. How is it? Do you know how well it's being supported? I mean, okay, so New Zealand isn't collecting anything like this, enough information like this, let alone carrying on funding or research. How is Europe performing along these areas, and the UK and the USA, do you know? And Japan, say.
Yeah. Yes, so they're complicated. It's a complex question. First, let's stick with the New Zealand case, right? We've had a few attempts of, for example, you might or might not be familiar with the Kapiti Coast, where the Kapiti Coast Council did this research on what is the likely future exposure of houses along the coast to coastal erosion because of sea level rise. And they posted the results of this research about 10 years ago on their website, and they added that to the LIMS, to the Land Information Memoranda that people can view when they, for example, buy a house. And then they were taken to court by some homeowners that were worried that it will affect their property values. And ultimately, the council lost and was forced to remove the warnings from the LIMS and sort of go back and try again. They lost on sort of not because the courts necessarily said that you can't give those warnings to people, but they said that there wasn't enough science and the science was not established enough, and the research probably didn't consult enough, and so forth. So council went back and only recently started again to issue warnings about future coastal erosion for specific house. And I think they started that last year, but maybe someone knows the timing more than I do. And that process had a chilling effect on local governments across New Zealand because they saw what happened in Kapiti and realized that exposes them to sort of protracted legal fights with interested homeowners. So it's not necessarily the government that is not interested in providing this information. There are various interest groups, sometimes wealthy and powerful interest groups, that are not necessarily interested in the provision of this information. In the US, they try to put some, the US doesn't have a better system than we do. They did, their flood mapping is probably marginally better than ours. Ours is not very good. It's very well. It's not very good. It has very varying quality across territorial authorities because it's at the regional level, because it's done regionally. There is no national flood mapping in New Zealand, right? And each territory each area has its own approach and its own capacity to do flood mapping. So we have very variable quality to flood mapping in New Zealand to current flood risk. So projecting forward for flood risk because of climate change, we're not even measuring the current flood risk very well. So not to speak of the future. In Europe, there's variety across countries, but we saw, for example, Germany last year, where there was big floods, and you may remember there were a lot of deaths as well from this river. I forget the name of the river that flooded, so again they realized, okay, our flood risk is changing, and our maps are not up to scratch because they're based on historical data, which is no longer applicable. Okay, that's part of the problem. A lot of the flood mapping that is done in New Zealand and elsewhere looks at the history of, say, the last 100 years of an area and looks, what's the extreme rain events in those 100 years, and from that estimates what, for example, a 1 in 100-year event looks like. Now, of course, if the climate change changing, that's no longer an appropriate approach. Okay, so I think I would say, sort of briefly, Jeff, the response is no one is really up to what you would consider, I think, adequate modeling of the risk, and definitely we are not there, or for that matter, the United States. Okay, in the case of Hurricane Harvey in Houston, about I think 70 or 80% of the houses that were flooded were outside the flood zone, outside the 100-year flood zone. Okay, let me talk about another paper that we've done recently, and is publicly available, but will be published hopefully very soon. And that is, we take the same approach, but now we are trying to do it globally. Okay, not specific events or not just floods in New Zealand, but all extreme weather events globally. So try to arrive at a global figure of the cost of climate change in terms of extreme weather events. And for that, we collected all the attribution assessments that have been done. So there's been about 250 published papers for almost 200 extreme weather events. We collect economic data, we match everything together. I'm not going to sort of give all the details. The details are available in the paper, but just to show you what we know from looking at that attribution. So this figure just shows you what is the changing risk for these 6 types of events. So, for example, if you look at heat waves. So heat waves are becoming 77% more likely because of climate change, but there is a range between 1 and 20% and 100%, and that depends on the exact heat wave that one was analyzed, right? So some heat waves that we have seen globally have only become more likely by 20%, but some heat waves have become it's sort of 100% of their likelihood is because of climate change, or to put it differently, they would have been impossible without climate change. For example, the heat wave that we had this year in southern Europe, this was back in June, was deemed to be that 100%. An event, that 48.2 degrees that was measured in Italy, that would have been impossible without climate change. Okay, for flooding, for example, we see a much bigger variation. So some events in some places on average, flooding is becoming 20% more likely, but there's a very big range. And in some areas, flooding is becoming less likely. And in some other locations, flooding is becoming more likely by 80%. Okay, so there's a very large variation in flooding. You won't be surprised if you look all the way at the right that cold events are becoming less likely. That's true globally. Okay, by how much? Well, that depends on the location. But some cold events are becoming impossible now because of climate change. Okay, that's that -1. Okay, and then we match that with economic data, and we can calculate what is the climate change attributed loss from extreme weather events. This is as % of global GDP. So you see it fluctuates from year to year because some years have very big events and some years don't. 2003, 2008, and 2010 are ones with very big weather events. And you can see that roughly about half of the overall cost of extreme weather events is because of climate change in the past 20 years. Okay, now it's hard to know whether these are large figures or not, so just let me give you a number for this. The average here is annually $143 billion because of climate change. Okay, now is $143 billion a big number? Again, depending compared to what. I think the easiest comparison is to how much are we spending on impacts and adaptation right now. Okay, and we have a decision within the UNFCCC, the United Nations Framework for Climate Change, that talks about, this is already in the Paris Agreement, talks about spending $100 billion a year for adaptation and impacts. Okay, so about 10% of that is supposed to be spent on impacts, on dealing with the impacts of climate change. So about $10 billion. Okay, so that amount, $100 billion, was never made available. It's just a figure that in Paris they agreed in principle to spend. Countries didn't contribute the amount, so what was actually spent was much less than that. But even this aspirational amount, $10 billion for impact, is much bigger. It's much smaller than the actual impacts of climate change that we are already experiencing right now. So these are, in the last 20 years, on average, $143 billion. So we have on average $143 billion. We promised to spend $10 billion on it. We haven't done even that, but we promised to spend $10 billion on sort of this idea of dealing with the impacts. Okay.
Ilan, may I ask a question there? Often
yes,
in my work, what crops up is the cost of action versus the cost of inaction, and your discussion now is very much in that space. But
yes.
The 143 billion that you show in red there, I guess I'm hoping that you'll come up with some figures at some stage for us. What would we have had to spend to avert that, maybe? Or I know you won't be able to be precise about it, but I mean, I know Lord Nicholas Stern, for example, said that he grossly underestimated the extreme benefits of paying for climate action rather than paying for the cost of inaction. Will you be going into that territory anymore with us tonight?
No, not globally. So one of the reasons Nick Stern underestimated the sort of the benefit to cost ratio is exactly because he ignored his report. That this is the 2007 Economics of Climate Change report.
Mm-hmm.
Ignored this issue of extreme weather events, or didn't try to quantify the issue of extreme weather events. I'm only quantifying extreme weather events. I'm not quantifying all the other aspects, all the other consequences of climate change, many of them very adverse. Okay,
Sure.
so this has nothing to do with sea level rise. This has nothing to do with ecosystem collapse. This has nothing to do with environmental damages. This has nothing to do with decreasing productivity because of heat, increasing heat, the increasing cost of energy that you need to cool things. All of that stuff is not quantified here. I'm only quantifying the cost of extreme weather events. Okay. So this is not, you shouldn't interpret this as the figure that, what we would have saved had we dealt with the problem, had we averted the problem by reducing the amount of greenhouse gases in the atmosphere. We would have saved a lot more than this. Okay. So to have a full assessment of the cost of action versus inaction, as you suggest, you need to quantify a whole set of other things other than this. Okay, both in terms of the cost of mitigation, so what would have been the cost to the economy of reducing greenhouse gases, but also a lot of the benefits of averted other types of damages that I'm not even quantifying, right? So you're not only going to be averting that $143 billion, you're going to be averting a lot of other stuff as well. Okay.
Yeah.
The tools to do these, I think, are so imperfect that I'm not sure how much I believe in the number. So you can develop a model that would estimate a lot of these things, and this is what we do with integrated assessment models. I'm not a very big believer in those models, and therefore I don't do that. What I like to do is focus on the past and measuring the past, because the past is something we already counted, right? Rather than trying to model the way the economy would have looked like without climate change, and then model, for example, what productivity would have looked like with lower temperatures and so forth. Okay, I think, and to me, in a sense, the cost of inaction is much higher than the cost of action. I think that seems to me to be an obvious statement. Okay, largely because the cost of action have been vastly overestimated. We know now that actually the transition is not that painful as people thought it would be. Okay, and therefore, to me, whether the benefit to cost ratio is 15 or 10 or 25 or only 5 doesn't really matter. 5 means the benefit is 5 times as much as the cost. It doesn't really matter because clearly what we need to do is much more mitigation than we're currently doing. And I think the reason we are not doing mitigation is not because it is too costly. There's other reasons that have to do with politics and things like that. And we need to concentrate on those rather than, further digging into the economic case for mitigation, because I think the economic case for mitigation is incredibly self-evident.
So Ian, with regard to politics, you have certain parties wanting to cut government costs and others that, less so. What about this data collection, accurate data collection thing, which some governments may, ones that may deny climate change or are in that sort of area, they may say they don't want data collection, for a number of political reasons. How do you view the ability of people like this group to lobby for the data collection and extending what you're doing?
The cost of data collection are not very large, right? So the objections to data collection is coming. I mean, the excuse is sometimes the cost, but that's not the actual reason, because the cost of data collection are not very substantial. So if we were to start, so I would give you a very specific sort of bugbear that I have, and that is, you already heard the fact that New Zealand doesn't collect disaster losses data. So we don't know how much Cyclone Gabrielle cost us. What was the extent of the damage? We don't know, and we will never know because we are not collecting this data. Okay, so we have a lot of government entities and private entities spending money on fixing their assets and rebuilding them. So that, you know, the Ministry of Transport and the Ministry of Education and the Ministry of Health and ACC is paying some, and MPI is paying some, and MB is paying some, and private insurers and the Earthquake Commission and private sector uninsured assets are being replaced, funded by private sector owners, and so forth. And we have no idea what the aggregate figure here is. And we will never know because we don't collect that data. I've been trying to say to the government for 7, 8 years now that we need to collect this data. Because if we don't know what is the cost of these events, in a sense, what we don't measure, we don't manage, right? That's sort of, it's a cliche, but it's a true one, okay? We can ignore the amount of the sums that are being spent on extreme weather events in this country if we don't measure those sums. And that's what we have been doing. Now, recently, Statistics New Zealand came with a new strategy for sustainable data collection for the future. Initially, they contemplated adding this to their data collection effort. So starting to develop a disaster loss database for New Zealand. And sometime in the last few months, they decided to drop it for reasons that are not entirely clear to me. So if you have any power and you can convince the government that this is a worthwhile exercise or worthwhile thing to do, that would be, I think, very valuable, because once we understand the extent of the problem, then we'll start to get more serious about these extreme weather events. And I don't think we are serious enough about them now. I should note that about 100 countries collect disaster loss databases, including some of our Pacific neighbors. So, you know, Samoa and Tonga have disaster loss databases, for example. Australia is developing one. The EU has developed one. The United States has recently developed one. The UK. Some countries have been collecting that data for decades. And we seem to be laggards here. Again, for reasons I'm not entirely clear, because ultimately it's not very costly to collect that. I don't know if this answered your question, but we clearly have a data problem, and we are not trying to fix it at this point in time.
Well, yeah, we don't seem to take notice of the rest of the world, and we bumble on our own path. But we equally don't find our own data to bumble less, you know. So there's something for the government there to think about if we can get in their ears.
Yeah, I should also note that we signed the Sendai agreement on disaster risk reduction. So we are one of the, basically all countries, I think, except North Korea, signed on the Sendai agreement. This was signed in 2015. So the same year the Paris Agreement on climate change was signed, there was another agreement on disaster risk reduction. And in that agreement, every signatory to the agreement is mandated to report to the United Nations their disaster losses every year. So every year, our statistics agency, Statistics New Zealand, receives a request from the UN for this data. They scratch their head. They understand they don't have the data. They contact NEMA, the National Emergency Management Agency. NEMA said, we don't have that data either. And then they report the number of deaths we have every year. So every year, that's the only piece of information we report, because we have nothing else to report. We do count our dead, in a sense, and that's about it. Okay. So yes, question?
Sorry, just coughing.
can I continue? So, so some of the sort of ideas of what you can use this kind of approach, the kind of approach I described in terms of assessing the climate change cost of extreme weather events, you can use it like I just argued for something that will compensate countries for disaster losses. So since we can identify the climate change component of disaster losses, that can be a basis for what we call the loss and damage fund. The loss and damage fund is a fund that we just agreed on last year. We, the world, agreed on last year in the last big climate change meeting that was done in Egypt in November last year. And we agreed to establish this loss and damage fund and to start paying to vulnerable countries the losses that they are experiencing because of climate change. So this kind of quantification can help us estimate or help us determine how much needs to be paid. It can also be a tool to identify liability of big emitters. So, for example, there is one famous case is the German electricity company RWE, which is roughly responsible for 0.1% of global emissions in the past 100 years. Okay. Why does it 0.1%? That's a very big share of global emissions. Why? Because they've been in existence for 100 years and they use mostly coal to produce electricity. So they're the biggest corporate emitter globally, historically. Okay, so if they are in a sense liable for 0.1% of that $143 billion. Now it's only 0.1%, but of course 0.1% of a very big number. So they're still liable for quite a big number. And there is attempts to there's actually an attempt to sue them for climate change damages in a German court, but German courts work very, very slowly, and that has been in sort of going through the courts in the past, I think, 6 or 7 years. There's another issue I think that could be quantified here, and that is personal responsibility. So if the global impact of the climate change global impact of extreme weather events is $143 billion, we can actually identify the personal culpability, in a sense, of every person around the world, given their age, given their nationality, given their profession or their lifestyle, how much of that is from your own emissions. Okay, so I'm a 53-year-old Israeli, and I live in New Zealand now. So you can look at how many years I lived in Israel and how many years I lived here. You can look at the per capita emissions, average emissions of someone of my age and my gender and my whatever profession and so forth, and you can then develop a number that says, okay, I'm responsible for, I don't know, a certain amount of that $143 billion. Okay, we're working on a project that will do exactly that, although we don't have sort of actual results yet. But I'm working on that with some people from the UK Met's office. Okay, now a question that was asked about insurance. This is another project. So this has nothing to do with attribution. Here we are looking at specifically about insurance, and specifically about insurance for coastal property. So in this case, these are properties that are in the 100-year flood zone in Auckland, Wellington, Christchurch, and Dunedin. So we look at what is the likely evolution of climate change in those cities in the next few decades, what climate change will do to extreme weather flooding in those cities in the next few decades, and what does that mean for insurance? Okay, where we argue that insurance is likely to fully retreat if the risk is already at the 1 in a 25-year. So full damage to a property at once every 25 years. In that case, insurance is no longer available. It starts to retreat at about, if I remember correctly, 1 in 40 years. Okay, so as the risk escalates, insurance first starts to retreat in what we call partial retreat, that might mean much higher premiums or very large excesses, or potentially hiving off some of the risk to a public entity, like we did with earthquakes, or potentially excluding some hazards. So for example, coastal properties where the insurers say, okay, we insure you for any kind of flooding except for storm surges, okay, or something like that. And then eventually full retreat, meaning the insurance is not going to be there anymore for those types of hazards, okay? Now, you can see that in each city, it starts in a different sort of, in Wellington, it starts earlier than later, but within 20-25 years, all of these properties are no longer insurable, okay? Privately insurable, okay? One worry that I sometimes have is that because they're no longer going to be privately insurable, the government will step in and insure them in perpetuity. And that, of course, that is what happened in the United States. So the government stepped in and said, no worries, the private insurers don't want to insure, so we will provide the insurance. So you will always get cheap subsidized flood insurance, don't worry. And what they ended up with, of course, is they're subsidizing a lot more built up on the coast, because the government is saying, you can build on the coast, we will provide you the insurance, or you can build in the floodplains, we will provide you the insurance. You have already been flooded, don't worry, we will provide you new insurance if you rebuild there. And you have properties in the United States where they've already been flooded 20 times, and the government is still insuring them. So the same property, having flooded 20 times, is still being insured when they rebuilt in the same location. Okay, this is an outcome we clearly don't want. So what will happen when insurance starts to retreat, or it's already starting to retreat in Auckland, right? After the January flood event, insurers already announced that they're going to, some properties are not going to be insurable anymore in Auckland and in the East Coast. And so that process usually starts after big events, and we end up with no insurance. What happens then is a big political question, and a complicated one.
Ilan, may I ask if Belinda's Story's concept of a climate lease has got any traction, because that seems to have a bearing on this situation.
Climate leases?
Yes, her idea of a diminishing lease over a period of time associated with the flood risk of a property at risk.
Yeah. So that idea of climate leases. So the basic idea is, if you have a property that is at increasing risk of climate change, or increasing risk in the future, it will have very high risk for say flooding event or storm surges or whatever it is. The government can buy off that property from the individual and provide a lease to that individual to keep living in the property for some stated period of time. So, for example, if we think that that place will no longer be insurable or defensible or safe in 20 or 30 years' time, the government buys it and provides a 20-30-year lease to the individual to keep living there. So essentially, converting the properties from fee simple to leasehold land. The government initially was interested, let me put it this way. The current government has lost all appetite to do anything that is substantial, because it's election year. So there's no appetite for anything at this point. And I don't have to tell you this, I think. Every 3 years, we have a year in which nothing gets done. Because it's election year. This is not any different. This year is not any different. Whether the new government that will be voted in resurrect that interest in climate leases, I don't know. And this is something I want to talk about briefly, so I'm going to skip here because I see I'm a bit tight on time. And this is the issue of managed retreat, okay, which is connected to climate leases. So with managed retreat, the idea is you can basically do three kind of things when the risk is changing. You can either resist, so build seawalls.
Are you listening to music?
I'm
in a webinar.
You can either resist, meaning build seawalls. You can accommodate, maybe putting houses higher so they can accommodate occasional storm surges, for example, or you can move the house, right? And how exactly to do that? And part of the sort of the menu of possibilities would be for houses that might it might not be feasible for them or economically advisable to resist or to accommodate, to provide a temporary climate lease on them until they actually have to be retreated from. Okay. Now on that part, just yesterday, the government issued 2 reports on this issue. One was a report by the government. It's called Community-Led Retreat and Adaptation, Funding Issues and Options. And the other one is a report by an external expert working group, of which I was a member, in which we proposed a system of what we call planned relocation. Okay, so managed retreat. And we proposed a system in which, we propose a system exactly sort of both we propose a system on how to identify those properties, what are the legal mechanisms through which we can do it, and what funding should be involved. Okay, so that report has very specific advice on how we think such a system should be designed. The idea of climate leases is not in there, but it's mentioned as part of the menu of options that should be explored. The government took a sort of, out of that report, the government issued its own sort of report that was developed by the Ministry for the Environment, and that report has much fewer details and is much less clear about exactly what kind of process of planned relocation the government is envisioning. Parliament is going to start its own sort of discussions about that as well. Okay, so this is a lively issue. It's a lively issue because we have possibly a couple of thousand properties in Auckland and on the East Coast, which may need to be relocated, right? So the government already announced these category 1, 2, and 3. With the first category, those houses that are definitely not going to be allowed to be built back, and they're definitely going to be bought by the government, and people will be compensated for that. And then that involves a few hundred houses, and then a bigger group of houses where the government is still unclear whether it will be able to allow people to rebuild those houses, subject to some additional flood protection measures, or it will again buy those people out. So the government already said that they will buy some properties and we may buy some other properties, although the government is still silent about how much they're going to buy them for. Somewhat surprisingly, because we're already 6 months after those events. So the owners of those properties are still in limbo because they're not sure exactly what they will get, and that doesn't allow them then to go on with their lives, I guess. Yeah. So that's sort of a sidebar on this issue of climate leases and managed retreat. I definitely think that climate leases should be part of the issue, although there is a lot of things we still need to work out exactly how to structure climate issues, and more importantly, how to price them. And I would argue that when we are doing climate leases, we should do leases that are not for a specific predefined period of time, but rather are done in a way that allows the government to shorten the lease if there is a big event that causes damages. So not by, if we look at the Kapiti Coast, for example, not buy houses and then provide 30-year leases to those houses, because we don't know if those houses will not be damaged in those 30 years. So the lease should be conditional on how much future climate changes are going to happen, because we don't know, and on potentially the occurrence of very big events that might be damaging. So I don't think we should be in a situation in which we give a 30-year time span on a house, but then 15 years into it, the house gets damaged by a big event and we need to rebuild it for another 15 years, because that's not a wise use of resources. So we will need to structure a flexible climate leases program, and that is feasible, but needs to be done with the government that is actually prepared to do something. And unhappily, I'm not sure. Well, the current government, because it's an election year, is not really interested. I don't know. This was a long answer to a pretty short question about climate leases, so I apologize. I know that there is not much time left, so I'm happy to open up to other questions, or there's a few other things I can talk about, but I think maybe that's enough, and we can answer questions or any discussion that people want to raise, any points that people want to raise.
Well, thank you very much for this, Ilan. That you've left a tremendous amount for us to think about. I was going to ask you a question. What's your relationship with the government towards positively influencing government policy, and how might the ESR help? And I think you pointed us in that direction, and it's actually to gather data as a first step.
Yes.
Another thing I'd like to point out to everyone here, reading the book recommended by Ross in our newsletter, What We Owe the Future, by the philosopher William McCaskill, where he says the challenge is for us all to be setting a course of action towards positively influencing the future, most especially in the long term, is a key moral priority of our time. You know, all of this is exactly in that direction, but we've got to get going with it.
Yeah, I want to sort of add to that. So William McCaskill's point is that we think we need to think long term, and we find that challenging. So the argument is we need to think long term because everything we do right now doesn't only have an impact on us and our kids and our grandkids, but for many, many generations after that, because it gets transmitted. So for every death, for example, that we experience today because of, say, the extreme weather events, there is a whole host of people that will not exist because of that, right? So that's the long-termist argument that argues for a much stronger emphasis about the future. So we struggle with that, but the political system struggled with that a lot more than we do. So the political system doesn't even think beyond 3 years. So this is not just a long-termist argument about, we need to think 3, 4, 5 generations forward. We need to think 5 and 10 years ahead. And our political system struggles to do that. Not to say, of course, much more long-termist view of the world. And I think, to me, that's where the problem is. It's our political systems that don't don't support us to think about the future.
May I, Ian, may I say that that the data everything you presented here is really, really great. I'm not a data person, but I specialize in the sort of connecting with people at all different sort of levels, and if you ever get to produce the data, it's the manner in which it's presented to the person in the street that, forget the politics. We'll go past the middleman, we'll go straight to the people that matter. And so the challenge for us, and I work in another area in sociology, they have the same problem, is the ability for academics to present the data to the average person in the street in a manner that they connect with. And I think that's the biggest challenge, rather than lobbying politicians. I would, it's good fun doing that, but, I'll just throw that one at you as a thought.
Yeah, I think with the climate change problem, I don't think that's the issue, especially if you look this year about what happened in the North Island. This is a very present problem, and I think if you and the polling supports that, right? So there's I wouldn't say consensus, but there is a large majority, for example, here in Aotearoa, that supports climate action. Okay, so it's not the people in the street who are the problem. In terms of, I mean, we do have a strong farming lobby that lobbies against, but they're a very small minority of the population. They're very vocal and very powerful, but they're a very small minority of the population.
Yeah. I was more thinking. I was more thinking of the depth and the long-termness of the data that what the data is producing. Is that it's, much of it is all just in the now and what we see, but it's the appreciation of the depth and the long-term nature and effect of the data that you mentioned. That is the challenge, is to connect people to understand that. That's what I was saying. Yeah,
I mean, clearly we need to do, but I think we have done quite a lot in this space, and more should be done and more needs to be done. We actually have a planning and work in the city of Houston, where Hurricane Harvey occurred. Because we have identified for each house how much damage was because of climate change, we have a planned project to actually send letters to every household and say, do you know that your house experienced $25,000 of damages because of climate change? Okay, and then looking at does that convince people? Okay, Texas is a good place to start to do this kind of experiment, because Texas is a place where there is quite a lot of climate denialism. So is that a convincing way to convince? Is that a persuasive way to convince people that the climate change problem is something they need to actively be concerned about? We are trying to develop that project. So one of the co-authors on that Harvard project is a sociologist from Louisiana State University, and I'm working with him on developing this kind of sort of, in a sense, experiment to see whether this is actually a persuasive way to convince people. But I don't think, what I described in this lecture is not something very, to be quite honest, sophisticated. It's something I can easily explain to anyone. And I've been trying to explain this. I've given talks in quite a few public fora of various sorts. And, I don't receive the response that people didn't understand what I was saying. It seems like it's almost self-evident.
Maybe it's just a place where the further work is needed, I guess, really, isn't it? Yeah.
I agree.
It is fairly self-evident. The trouble with most people is their ability to prioritize problems and to see them through. So people might be quite aware that we've got to get on with climate change until there's a cost of living crisis. And this is really what's happening in the UK at the moment. They were sailing through, you know, looking quite promising, and then suddenly it's all going to grind to a halt because they have a cost of living crisis.
Yeah.
So, you know, how do we get through there? Now, there's an interesting proposition from transition engineering to look at, because engineers write safety into standards right around the world. It was just something engineers could do. It was never a political issue. They never asked the people for permission. Engineers just got onto the standards committee and wrote in safety. Maybe we did it too far and became too woke in some places, but we were able to achieve that. So transition engineering are now saying, can we do the same with sustainability? Let's just get on and actually change the standards without going to the politics or directly to the people.
Yep.
Is that a shortcut way that we should be working on as engineers for social responsibility?
Absolutely, yeah.
So I would be interested in contacting you later, Brian.
Oh, well, it's a lifelong exercise if you choose it to be, and it can be a bit of fun.
Mm.
Yeah, but brilliant talk. Thank you.
Thank you.
It has been a very, very powerful talk, and we're very grateful to you for all this work.